Hi, I'm an old guy and I do maths. Here's an interesting problem. What is the graph of this equation? On first glance, it looks like it might be a circle graph, but we can't be sure. Let's do some work on it. The first thing I'm going to do is I'm going to take out the common factor here. So 3 into x squared plus 8x plus y squared plus 36 equals 0. Now, for the moment, I'm going to treat this as if it is the equation of a circular graph, and I'm going to do what I would normally do, which is I will complete the square, or start completing the square for this part of the equation. So that gives me x squared plus 8x. Half of 8 is 4 plus 16, y squared plus 36. 16 threes are 48, so I'm going to subtract 48 from the end of the equation just to keep everything in balance. And when I tidy this up, I get 3 into x plus 4 all squared plus y squared minus 12, that's 36 minus 48 equals 0. And I can tidy this a little bit further. 3x plus 4 all squared plus y squared equals negative 12. Positive 12. What am I saying? It is positive 12. Now, I still have a problem, which is this thing. And in order to deal with that, what I'm going to do is I'm going to divide through by 12, because what that's going to give me is it's going to give me 1 here, which if I need to, I can find the square root of very easily. But it's also going to get rid of this. However, what it lands me with is the following. We'll just do this one first and this. And then we'll look at this. 3 divided by 12 is 1/4. So that is x plus 4 all squared over 4. And that's what the fundamental equation, in as near as you could call it a sort of a factorized form, looks like. It's a form in which we can work on this, but it is not the form of a circular function, nor is it the form of a hyperbola. And I've just got an old note here just to show you the difference. We've got the 1 on the end of the equation, all right. This may be something squared. That certainly is 2 squared. But we've got a positive y squared here, and this is negative. So a hyperbola it is not. What it is it's an ellipse. And I'm just going to attempt to sketch the graph of it kind of quickly here. Now, the way in which we make the way in which we make this bracket equal 0 is we make x equal negative 4. So that puts our point here at negative 4 on the x-axis. How we make y equal 0 is we simply make it equal 0. So this point here is negative 4, 0, and that is, if you want to call it that, it is the center of the ellipse. Now, the distance from here to here and here to here is the square root of this. So this point here is negative 6, and it's negative 6, 0. I hope you can see that. This is very poorly sketched, and this point here is negative 2, 0. So we know that the ellipse passes through those 2 points. Now, what of the points here and here? Well, how we find those is by taking the square root of 12, And the square root of 12 is a third. I'll just do the working here. So that's 4 times 3. And that gives us 2 root 3. Okay, so our point up here is going to be the square root of 12 from here to here, which is 2 root 3, and negative 4. So negative 4, 2 root 3. I hope you can see that. And so this thing comes down here like this. And there's a corresponding piece down here because these are symmetrical despite how I draw this. And this is negative 4, negative 2 root 3. Okay, so those are the points of interest on the graph of this ellipse. There's quite a bit to take in here. And as I say, one could be very easily seduced into thinking that this is the equation either of a circle graph, or if you got to this point, you could make a simple mistake and say it's a hyperbola. Well, it's neither of those. It's the graph of an ellipse. And I hope you found this useful and interesting. If you did, please like and subscribe, and I will see you next time. Bye.